Welcome to The Explainer. Today, we're diving into some pretty mind-blowing technology, the kind that's taking artificial intelligence out of the digital clouds and giving it a physical body, one that can actually see, interact, and do things in our world. To really get our heads around just how big a deal this is, let's start with a little thought experiment. Just imagine an intelligence that could solve the most impossible equations, write incredible poetry, paint masterpieces, but it couldn't actually see the world it was describing.
For the longest time, that was pretty much the reality of AI. We had this mind with immense power, but it was fundamentally limited. It could think, sure, but it couldn't perceive. It could describe a wrench down to the last molecule, but it couldn't feel the cool metal in its hand. It was, for all intents and purposes, a ghost in the machine.
And this limitation wasn't just some minor detail, right? It created this huge, fundamental barrier, a solid wall between the world of digital thought and our physical reality.
So here's the crucial point. Without senses, AI had zero real-world context. It could process 1 billion articles about a cup, but it couldn't grasp the simple act of picking one up without spilling coffee everywhere. It was this brilliant intelligence completely trapped behind a one-way mirror.
But now, a breakthrough technology is absolutely shattering that mirror. It's giving this digital mind a real physical presence, and honestly, it's kicking off a whole new era of intelligence.
And this, right here, is the key. It's all about something called Vision Language Action Models, or VLAs for short. You can think of them as the tech that finally gives AI eyes to see, a voice to understand our commands, and hands to actually get things done. So, how does it work? Well, it's actually a pretty elegant 3-step dance. First, vision lets the AI see and make sense of its surroundings. Next, language processing allows it to understand what we want from it. And finally, action. Well, that lets it translate all that understanding into complex physical tasks out here in the real world.
Here's a great way to think about it. The old AI was kind of like a scholar who's read every single textbook on engineering, but has never actually touched an engine. This new embodied AI, that's the master mechanic who could read the manual, see the broken part, and know instinctively which wrench to grab. It's this massive leap from just passive knowledge to active, applied skill.
Okay, so let's make this real. Let's look at a practical example, because this is where it gets really cool. We're not just talking about following commands anymore. We're talking about real collaborative problem solving.
I want you to imagine an engineer, a Lara, in some high-tech lab. She's got a serious, high-stakes problem on her hands. A super-sensitive sensor is knocked out of alignment. The whole setup is delicate, the environment is volatile, and oh yeah, the repair manual is 3,000 pages long.
And get this, look at the tiny margin for error we're talking about. The sensor is off by just over 2 degrees. A tiny, tiny error, but one with potentially catastrophic consequences if it's not handled perfectly. Now, in the old days, fixing this, that would mean hours of painstaking programming. But Alara, she doesn't write a single line of code. She just talks to a robotic agent, giving it this complex, context-rich command.
And this is the absolute game changer. A traditional robot is basically a puppet. It can only follow the strings of its pre-written code, period. But the VLA agent, it's a partner. It interprets her words, scans that entire manual for the safety rules, visually spots the exact right tool, and then invents a brand new, super precise action sequence, all on the fly.
So you can see how this scales way, way beyond just one lab, right? This leap from a pre-programmed tool to an adaptive partner has massive implications for our world. It's the big shift from simple automation to true autonomy. And let's be super clear on the difference here. Automation is all about doing what you're told, over and over again. Think of a robot arm on an assembly line. But autonomy is about understanding the goal, the big picture, and then figuring out for yourself the best way to get there, even if the situation is new or totally unpredictable. And once you unlock that kind of autonomy for AI, wow, the applications just explode. We're talking about personalized healthcare on a whole new level, hyper-efficient smart cities, logistics networks that can coordinate millions of packages flawlessly, even assisting in complex surgeries with superhuman precision. The potential surge in productivity is unlike anything we have ever seen before. So this isn't just another upgrade to the tools we already have. This moment right here, it represents a completely new kind of interaction between us and our technology. The ghost isn't just in the machine anymore, it's walking right alongside us. And that
That brings us to what might be the most profound change of all. What this new partnership really means for us, for humanity.
See, by handing off all these incredibly complex physical and logistical jobs to autonomous agents, we get freed up. It allows us to redirect our focus to the stuff that is uniquely human, our creativity, our strategic thinking, our scientific curiosity, and our ability to connect with each other.
And make no mistake, this isn't some distant science fiction future we're talking about. This technology is being built and rolled out as we speak. This convergence of digital intelligence and physical action is rewriting our story right now.
So really, it all comes down to this. The conversation is shifting away from just, what can this AI do for us, to a much more interesting question. What will we, as humans and intelligent machines, create together? This is the dawn of a new kind of collaboration, and the possibilities are only just beginning to unfold.